This video is on gonadal development. Gonadal development. Now traditionally, females hold the sex chromosomes X, and males have X, Y. And when a female and male come together and reproduce, the female will make an egg that holds the chromosome, the sex chromosome X, always, because that's the only ones they have. Males will produce sperm that can either have an X chromosome or a Y chromosome. And those two get together, starts dividing, and ultimately makes your zygote and your embryo. And at around week 6, you start to create the foundation of your gonads. And these include your mesonephric duct. Your mesonephric duct plays a role in your urinary tract system, but it also plays a role in the male reproductive system. So mesonephric duct, M for mesonephric, M for male. This can be called, the non-scientific name is called the Wolffian duct. And cells in your mesonephric duct also form something called the indifferent gonad. Indifferent gonad. And the name gives it away. These gonads can become different things depending on whether it's a male or a female. All right? So those are your indifferent gonads. Well, how about female structures? Right next to your mesonephric duct, you have para-mesonephric duct. Para-mesonephric duct. Also known as Mullerian duct. And these help create female gonadal structures. All right? All these plug into your cloaca. That's basically the groundwork, the foundation at week 6 of what will ultimately become your gonads. Now let's just take a couple steps back. The egg is X. The sperm can be X or Y. So if the sperm is an X, you have XX, and you create female gonads. If the sperm is Y, you have XY, and that creates male gonads. Let's just follow XY first. The most important thing is that Y chromosome. Okay? In that Y chromosome, you have something called the SRY gene. And very blatantly put, is called your sex determining region of the Y chromosome. And that creates SRY proteins, which cause your indifferent gonads to become testicles. So your SRY proteins turn your indifferent gonads to testicles. And those testicles will start to produce substances, hormones. These include anti-Mullerian hormone. What on earth could that be? Well, anti-Mullerian hormones will degenerate your Mullerian duct. So these Mullerian ducts will ultimately disappear. And that's good for us, because those would have become internal female structures. With that gone, we don't have that. So all that's left is your mesonephric duct and your gonads that are now testes. These testicles also produce testosterone. That is the big male sex hormone, and testosterone turns your mesonephric duct into your internal structures. Male structures. Very important you know that. Testosterone develops your male internal structures. So it turns your mesonephric duct into things like seminal vesicles, vas def, epididymis, all those things. So again, just to reiterate the fact, testosterone creates your internal gonads. How about your external gonads, like your penis? Well, testosterone gets converted by an enzyme called 5-alpha reductase into an even more powerful form called DHT, or dihydrotestosterone. And DHT, associate that with external development. For our intents and purposes, whenever you hear DHT, think external. Whenever you hear test, think internal. And that is male gonadal development. Well, how about female development? Let's just redraw our structure. So you have your paramesonephric duct, aka your Mullerian. And these indifferent gonads are still indifferent. So you have your paramesonephric duct, you have your mesonephric duct, and you're still indifferent gonads at this point. So we're back at week 6. If the egg is X and the sperm is, in this case, X, you get XX, you make your female gonads. And without the Y gene, so no Y gene, you never go down this pathway. You never make your SRY proteins, you never make your testicles. Without that SRY genes, you fall back to your default, and the default gender of us all is the female gender. And so your gonads don't get the SRY protein, no, to go back to default, and that default is going to be your ovaries. So these become ovaries. And with no testicles, you don't make the things that testicles make. What were those again? Anti-Mullerian hormone, testosterone, correct? So no anti-Mullerian hormone. That means your Mullerian ducts never degenerate. And no testosterone. Remember, testosterone turns your mesonephric duct into internal organs. Without testosterone, mesonephric ducts are what degenerate. So no testosterone equals Wolffian degeneration. And when that degenerates, you will have your female gonads develop. That is gonadal development. Now let's see how things can go differently. So normally X from the egg will meet up with X or Y. And the most common sex chromosome abnormality is called Turner's syndrome. So Turner's. And this occurs when a female only gets one X chromosome for whatever reason. So genotypically they're 45 instead of 46X. Sometimes it's called 45X0. Whatever the case is, 45 chromosomes are missing that extra X. Now the catch-all is, could they have 46 and be a mosaic? Yes, they could. So they can express mosaicism. Just keep that in the back of your mind. We're not going to talk too much about that. That's more kind of genetics. But this is the most common sex chromosome abnormality. And when you have a missing X, then your ovaries don't develop as they should. When your ovaries don't develop as they should, what hormone does your ovary make again? Can you remind me? It makes estrogen. Estrogen. So you're going to have decreased estrogen. What regulates your ovaries? FSH, follicle stimulating hormones. It wants to stimulate the follicles in your ovaries. So when it sees your ovaries are shot with decreased estrogen, it's going to want to try and bump that up. So you're going to have very high FSH, you might have high LH, all those gonadotropins. And when your ovaries don't develop as they should, then it makes it very hard to ovulate and menstruate. And so a lot of these patients have amenorrhea. In fact, it is the most common cause of primary amenorrhea. Now, there are some very strong physical characteristics of Turner syndrome that you should know. These include short stature, lymphatic defects. So they can have lymphedema, they can have a really broad chest, they can have a webbed neck. So I'll just say lymphedema. The large webbed neck is usually, I guess, a telltale sign. They can have lymphadenopathy. They can have a collection of lymph fluid around their neck called cystic hygroma. Cystic hygroma. And whenever you have lasting lymph fluid and lymph collections, it can always predispose you to lymphatic cancer. So lymphangioma. That's just a general principle. Just a side note, if you have breast cancer and you do surgery and you remove that breast and you also remove some lymph nodes, you can have long-standing lymphedema, and that lymphedema can become lymphatic cancer. So anytime you have long-standing lymphedema, you can have lymphatic cancer, so know that. You can also have CVS defects, so heart defects. Some of these include bicuspid aortic valve, and probably the more important one is preductal coarctation of the aorta. So that is a lot of information. That is a lot of characteristics. What do we do when we see a ton of characteristics? We kind of synthesize them all into a step-like question. So we grab some from here, grab some from there. Just coming off the top of my head, a gal comes in, primary amenorrhea, short stature, has a cystic mass on her neck, which is this. What do you expect to see on laboratory or lab findings? Decreased estrogen, increased FSH, etc. Or we'll say a gal comes in with short stature, lymphedema, webbed neck. What cancer is she predisposed to? She has dysfunctional ovaries. Do you remember during our talk on ovarian cancers, what kind of ovarian cancer does dysfunctional ovaries predispose you to? Dysgerminoma. Very good if you got that right. It's in the name. Dys meaning abnormal, germ meaning your germ cell, meaning your ovary. Dysgerminoma. Okay, that's Turner syndrome, the most common sex chromosome abnormality. Let's go to the next one. Klinefelters. Klinefelters affects men, and this is when they inherit an extra X chromosome. How would that look like genotypically? That would be 47XXY. And that extra X chromosome causes malformation of your testes. You're going to have abnormally small testes. And not only are they going to be small, but they can't produce what testicles produce. Do you remember what testicles produce? Well, they produce anti-Mullerian hormone. But I guess after your embryological period, when you don't have any more Mullerian structures, then this kind of shifts into another inhibitory hormone called inhibin. That's kind of a nice giveaway name, inhibin. You also produce things like testosterone. I just wrote testes. Testosterone. Right? Those are the two things we talked about. Just kind of for your knowledge, the thing that produces these inhibitory hormones are going to be your seminiferous tubules. And then the thing that produces testosterone are going to be your Leydig cells. That's just some stuff, some facts you should know. So you can't make these two because you have dysfunctional small testes. What does this cause? Well, the most important thing is without testosterone, your body will notice that. Try and increase testosterone in any way it can. So you're going to have increased FSH, LH. That'll be just on lab findings. But clinically, if you have decreased testosterone, you're going to have a very tall body because testosterone is what closes your epiphyses. So decreased test equals tall body. You're going to have infertility issues because your gonads aren't functionally working as they should. So infertility. And also, those with Klinefelters, they produce a little more estrogen than they should, whether it's from the extra X, whether it's just from the decreased testosterone. There's an increased amount of estrogen. And that increased amount of estrogen, you can have female characteristics like gynecomastia or gyno or breast tissue. What does it say? Gyno. You can have, or a more female shaped body or more female pattern of hair distribution. All of these are more clinical, I guess, physical characteristics that you can see in a patient with Klinefelters. So again, a lot of information. Let's emphasize that into a step-like question. So off the top of my head, patient comes in complaining of infertility issues with his wife. You do a physical exam, you notice very small gonads. Gynecomastia, what do you expect on laboratory findings? Well, decreased testosterone, increased FSH, LH, or they might say, what is the possible genotype of this patient? 47XXY. Comprende? That is Klinefelters. Just a few more. This one also affects males. Instead of a extra X, you have an extra Y. So we call this the double Y males. What do you think their genotype will look like? Hopefully you say 47XYY. Relatively common, I think, is 1 in 1,000. Probably more underdiagnosed than anything because there's not very glaring physical characteristics. They're just a little taller than usual. They might have a little bit more severe acne. And they might display aggressive or antisocial behavior. So I'll just write aggressive behavior. And again, these are kind of non-specific symptoms, so they'll have to give you more. They might just give you the genotype and say, what do you expect to see in this patient? I think that'd be a better way to do it than give you the symptoms and say, what's the genotype? Because that's just way too non-specific, okay? So just kind of know this superficially. Probably the acne and the aggressive behavior is from the extra Y chromosome, maybe possibly more testosterone than normal. But know the genotype, know, I guess, the characteristics of this genotype. That's sex chromosome abnormalities, but we talked about way more than just sex chromosome. We talked about hormones and how they come into play in your gonadal development. So this next part, we're going to talk about those hormones and what can go wrong. The first one we're going to talk about is androgen insensitivity syndrome. Androgen insensitivity. So in males, remember when you have your SRY, we'll just recall this, makes your SRY proteins, which turn your indifferent gonads into testes, and that testes creates AMH and testosterone, correct? Androgen insensitivity syndrome is when testosterone can't bind to its receptor. Maybe that receptor is mutated. So you make a lot of testosterone, but it can't bind to its receptor. And if it can't bind to its receptor, then it's no good. It can't stimulate the effects, yeah? And so let's see what happens to the internal genitals. What controls your internal genitals? Can you remind me? They'd be your testosterone. So without working receptors, you don't make your internal genitalia. It's no good. So no male genitalia? How about female genitalia? Do you make those? No, because you're making anti-Mullerian hormone to degenerate that. That's perfectly fine. AMH is perfectly fine, so no female either. How about external? What makes your external male gonads? Can you remind me? If you said DHT, you're right. So testosterone gets converted to DHT. Is there a problem with conversion of DHT? No, didn't say anything about that, right? So you're gonna have varied external gonads depending on your DHT level. If you have a little less, you might have, I guess, ambiguous genitalia. If you have more, then you can have male genitalia. So I'll just write varied. And then one last thing, what happens to your testes? What controls your testes? It's your SRY gene. So your testes can be normal. Sometimes if it's in ambiguous genitalia, it can be found in your labia majora. So that's internal, that's external, and then let's talk about lab findings. There's something unique to androgen insensitivity syndrome, and that is, in this syndrome, you have sky-high testosterone. Why do you have that? Well, if testosterone can't bind to its receptor, then your brain never registers it and thinks you have very, very low testosterone. So it starts pumping out more LH, which helps make testosterone. And so that just makes more testosterone. But that testosterone can't bind. And so it's a vicious cycle over and over. And so these two hormones are sky high. Know that well, okay? One last thing that's very important that I've been asked on questions before is, what do you do with the testicles found in your labia majora? Those testicles are very defunct and malformed. You don't leave them in. You have to surgically remove them. Otherwise, you run the risk of cancer. Remember, anytime you have dysgerm or dysfunctional germ cells, you run the risk of dysgerminoma. Okay, so you surgically remove that. Again, that's a lot of information. Let's synthesize that into a step-like question. Patient comes in ambiguous, not patient comes in, this would be a baby. So a baby's born. Ambiguous genitalia. On examination, you notice virilized genitalia and testicles in the labia majora. What kind of findings might you find on laboratory? Increased testosterone. They really like laboratory findings for these questions. So you gotta know these cold, all right? I've seen questions that have, you might have seen a ton of these on, if you do your world, it'll say like test, estrogen, FSH, LH, etc. And then they want you to, and then they have all these multiple choice questions that are like this, where you have to decipher which ones are increased and which ones are decreased. Those are very, very common, both on UWorld and the actual step. I've had a fair share of these, so always know the lab values, all right? One kind of less important lab finding that you might see in androgen insensitivity syndrome is increased estrogen. Why is that? Because an enzyme called aromatase turns androgens to estrogen. So testosterone really has a lot of routes it can go, right? We talked about how testosterone can turn into DHT. We talked about how testosterone can turn into estrogen. And that's a perfect segue into the other syndromes. So testosterone to DHT via 5-alpha reductase. What can go wrong here? Well, you can have a 5-alpha reductase deficiency. How would that affect your internal structures? What controls your internal structures again? Can you remind me? If you said testosterone, you're completely right. Is there a problem with your testosterone here? No. So you're gonna have normal male internal genitalia. How about your external genitalia? What controls your external genitalia? Can you remind me? That is your DHT. Is there a problem making DHT here? Yes, you can't convert testosterone to DHT. Okay, so you're gonna have varied external genitalia. You might have ambiguous genitalia. You might have a female external genitalia, okay? All you need to know is without DHT, you're not gonna have that normal male genitalia. So we'll write ambiguous or female. Now here's something very important. In puberty, us gents get a surge of testosterone, and that will force any little bit into DHT. That surge will increase that, and you will actually, in puberty, virilize and create male external genitalia. Okay? Very important. You know that there's actually a book written about that. I think it's called Middle Sex, about a person that was born phenotypically female. So I guess she grew up, associating herself with the female gender, assimilated into that female gender. And then during puberty, that surge hit and she grew a penis essentially. So if you thought your puberty was bad, I'm guessing that gal had it much worse. So this is an important fact you need to know about 5-alpha reductase deficiency. Okay, what do you find on labs? Testosterone is going to be normal. Work on the receptors, and if there's too much, then you'll tell your body, oh, hey, we need to cut it down. If it's too little, it can regulate because it's normal. So normal test. You're obviously going to have decreased DHT. I'm not even going to bother writing that. But just know you have normal testosterone and just can't really convert to DHT. Something else testosterone can convert to is your estrogen via aromatase. That's the next segue into aromatase deficiency. If you have aromatase deficiency, you can't convert testosterone into estrogen. So in babies, if they're still in their mother, they're gonna have very high testosterone. In male babies, it wouldn't really matter. In female babies, however, that extra testosterone will start to virilize the external female genitalia. All right, so it'll start to virilize genitalia. So you can have ambiguous genitalia, you can have clitoromegaly. Not only that, it can cross the placenta and virilize the mother. That's often how I see this question asked. They'll talk about a gal who's pregnant with a baby, and then all of a sudden they start getting hirsutism, so facial hair, acne, etc., and they might ask you, what's wrong? The baby's lacking aromatase deficiency, so they have increased testosterone. And that's what's virilizing the mother. Or they might just ask, when the baby's born, what can you expect to find if the baby's female? Virilized genitalia or ambiguous genitalia. Last but not least, there's one more. It doesn't really fit in with our I guess, our bigger picture, our story here. That is called Kallmann syndrome. Very, very rare, but they like to ask this for goodness knows what reason. Before I talk about Kallmann syndrome, just want to remind you, GnRH controls your, I guess, your puberty. It'll start at a basal level until you hit puberty age and then start becoming pulsatile. So it does that by controlling the hormones FSH and LH. So Kallmann syndrome is when your GnRH neurons don't migrate and develop in the brain where they should. And if you have that problem, you're going to have decreased GnRH, you're going to have decreased FSH, LH, and then everything downstream. So decreased estrogen, testosterone, etc. One other thing that can fail to migrate is your neurons in your olfactory bulb, your smelling center. So olfactory failure, and this culminates into failure to hit puberty. Patients will never go into puberty, and anosmia, which is a fancy way of saying they can't smell. You have those two, you have Kallmann syndrome. They might ask you what labs, because they like labs. What do you expect in Kallmann syndrome? Decreased everything. That does it for this video. Hope you enjoyed it. See you next time.